is going to be a review of some of the major concepts that we've covered in class so far. We're going to be using what we call a wave machine to demonstrate some of these major concepts. The first thing that we need to talk about is, what is a medium? A medium is a material in which the energy of the wave is transferred through. As long as it has particles, it could be considered a medium. So some examples of a medium could be water, it could be your desks, it could be you, it could be air. As long as it has particles, it could be considered a medium to transfer the energy of your wave. So anything that's a solid, liquid, or gas could fall under this category. So in this case, for our wave machine, there are several different parts that all contribute to the medium of our wave machine. So we have the tape, we have the skewers, and we also have the dots. So all of these materials together act as the medium for our wave machine. So for the first concept that we're going to review, we're going to start to look at the energy of the wave in relation to the amplitude of the wave. So right now, we can see that the medium is at rest, meaning it's at equilibrium. So as I perform this demonstration, I want you to choose just one dot that you can see in the video here. And as you focus on this dot, I want you to see how much its position changes from this resting position. So in other words, you want to look for how high it gets as I add energy to the wave machine. So I'm going to do two different examples of this. So for my first example here, I'm going to add just a little bit of energy. So choose that favorite dot of yours. And now I'm going to add a little bit of energy. I'm going to do this one more time. And again, I want you to focus on just how high your dot gets from this resting position. Okay, now I'm going to add a little bit more energy. And so as I do this, I want you to really focus in on that favorite dot of yours and look at how far it gets from that equilibrium position. Okay, just one more time. Now, as you can see, as I add more energy, what we can see happen to the dots is that they get further away from their equilibrium position, which means that the amplitude of our energy, of our wave, is getting higher, it's getting taller. So as more energy is added to the wave machine, it responds and it becomes a taller wave. So the amplitude gets taller. So the relationship then between the energy of our wave and the amplitude is a direct relationship. As the energy is increasing, we can see that the amplitude is increasing as well. Now, the next question is, what type of wave is being created here on our wave machine? So as I add the energy, we can see that the energy is traveling through the wave machine and it reflects and it comes right back. So it looks as though it's going in this direction. Okay, so it's moving to the left. Okay, now as the energy is moving to the left, pay really close attention to the direction in which your dots are moving. Check that out. Our dots are moving up and down, but the energy of the wave is going from the left to the right. Okay, so what that creates is a transverse wave. It means that the medium is moving perpendicular to the direction in which the energy is going. So it creates that right angle. So a transverse wave is in fact a wave where the medium's particles are moving up and down and the energy is moving from left to right. And so one of the ways we can tell that it is a transverse wave is we can see that the dots, which are the particles of our medium, are moving perpendicular to the direction which the energy is going. Now this time I want you to draw a transverse wave. Use this information to help you draw your wave. Okay, next we're going to create a wave that we call a standing wave. A standing wave is a wave in which appears that the wave is standing still. What does that mean? Well, it means that your wave doesn't appear to be moving in any particular direction. So for example, if I send just a wave pulse, it's very clear that the direction in which the energy is moving is down my wave machine and back. But in a standing wave, it would appear as though the wave is not moving in any particular direction. In other words, it looks like the crest and the trough just kind of flip positions, and it just looks as though your wave isn't going in any specific direction. So I'm going to create a standing wave, and as I create this standing wave, do your best to try to draw this wave in your OneNote. As you can see, it looks as though the wave isn't going in any particular direction. It's kind of hard to tell. Is the energy coming from the left? Is it coming from the right? In reality, it's kind of both, because what I'm doing is I'm meeting that reflecting wave, and I'm able to create this appearance as though the wave is standing still. So as I'm sending that energy down the wave machine, that energy is also getting reflected back. And so once I meet that rhythm of that other wave, it creates this standing wave. And you can see that the crest switches positions with the trough. And it oscillates and it goes back and forth and back and forth. Now the next task I'm going to task you with is to try to determine the frequency of this wave. We're going to do a 10-second time frame, and I want you to choose that favorite dot and focus in on how often it completes one wave. So to complete one wave, it's going to go up and then down. That would be one full wave. So you're counting how many times it completes that one wave. So up and down is 1, up and down 2, up and down 3, so on and so forth. So I'm going to do this for 10 seconds. Try to count how many waves your dot completes. Get that rhythm going first. I'll let you know when to start counting. You can start counting now. Okay, stop. Okay, record that number and then make sure to divide that number by 10, because we did this for 10 seconds. So that is going to be the frequency of this first wave. Now I'm going to create another wave, another standing wave. What I'd like you to do is do the same process. We're going to take time for 10 seconds. I'm going to just kind of up my tempo a little bit. So I want you to continue to count how many waves your favorite dot completes. I'm going to get the right tempo, and I'll let you know when to start counting. Okay, you can start counting now. And stop. Now once again, record that number and divide it by 10, because that was our time frame. This is going to give you the frequency of this second wave. Now once you've calculated those frequencies, I want you to determine which of the two waves had the greater energy, which one had the highest energy between those first two waves.